Okay, 7.5a, we are doing exponential equations. And if something is an exponential equation, it is because the variable is the exponent. Okay, the variable will be in our exponent this time. So, for instance, if we have something like this, okay, that's an exponential equation. If you have something like this, that is not an exponential equation, right? You need your variable to be part of your exponent, okay? So here is the process when solving exponential equations. There are 3 different steps that you are going to do. The first one is, I feel like so often the first step in a problem, and that is to isolate. For this one, when you're solving exponential equations, you isolate the power. So you want anything to the power to be by itself and every other number off on the other side. Okay, so we're going to isolate the power first. The second thing we are going to do is we're going to take the log of both sides. Whatever you do to one side, you got to do to the other, right? Golden rule of algebra. So we're going to take the log of both sides. The reason being, exponents and logs are inverses of each other, right? So if you think about, like, if I said x squared equals 16, and I want to solve that, I need to take the inverse by taking the square root of x squared, right? That's the inverse of x squared. Logs and exponents are inverses of each other. So if we're trying to get the exponent, the variable, figured out, we're going to take the inverse by taking the log of both sides. Okay, so we're going to take the log of both sides as our step 2. And then step 3, we're going to use one of our properties, the log base b of m to the n equals, where you put that n out in front. Right, so we're taking this n and we're just moving it out in front. Okay, so that's your 3 steps. I have 5 problems for you, and then we're done. Which might be some kind of record, I think. No, they're not super long. It's a pretty short lesson. Okay, so here's how the problem is gonna look. They're gonna say solve, and we're gonna round to 4 decimal places. Places. And just show your work on this stuff so you see where, if you go wrong somewhere, you know where you went wrong, right? Write down the problem, work it out, show me what you're doing. All right. Here it is. First one. If we have 16 to the 3x power is equal to 8. Okay, now we do not have a nice, easy way to solve that. So instead, we bring logs into the picture, and then it actually is pretty simple when you use logs with this. So the first step we said was to isolate the exponent. There is nothing on the left side of our problem that does not involve our exponent right now. Okay, so this one has been isolated for you. You don't have to do step 1 on this. So step 2 is to do what? Take the log of both sides. So we're going to say log 16 to the 3x power equals log 8. Okay, that was step 2. Step 3, we need to use our property, which is going to do what? Right, so we're going to take the exponent and we're going to move it out front, right? We're going to take this 3x and we're going to move it over here. So it's going to become 3x log 16 equals log 8, okay? We're ultimately trying to isolate x. What do you think you do next? Not subtract. We're going to divide, right? We're going to divide by log 16. Now, here's the deal with this. This is probably the only place that I feel like mistakes get made for silly reasons. When you plug this into your calculator, log 8 divided by log 16, try it. Plug it into your calculator. Tell me what you get. Okay, so some of you are probably getting 0.75, and some of you might be getting 0.82. If you're getting 0.82, you're not putting parentheses in where you need to. You have to make sure that you finish off this parenthesis, because what you should be getting right now is that 3x equals 0.75. Okay? How do you solve that? This is Algebra 1 at its finest. We're just dividing by 3. X equals... Okay, well, here's your chance to redeem yourself. X equals 0.25. That's not bad, right? That's okay? Hopefully? I have 4 more. That's it. All right, second one.
No, I get this.
Oh. It's okay if you don't. I just need to explain if you don't get it.
Let's go back.
Okay, it looks like this. Step 1, excuse me. Isolate the variable. It already is, right? Or sorry, not the variable. Isolate the exponent. Exponent is isolated. There's nothing behind the 6 to the 2x power. So then step number 2, you do what? You take the log of both sides. Totally, yep. If you want to just write this as one step where it's 2x log 6, that is great. So yeah, step 3, use the property, move that out in front, so it's going to look like this. What do you do next? Divide by log 6. So divide by log 6 here, divide by log 6 here. Make sure this parenthesis goes in, okay? So now you have 2x equals, because this is gone. Are you with me right now? Because you're sure talking a lot. So log 1/5 divided by log 6 gets you a negative 0.8982. And I don't even need to see that, you guys. If you're doing all this in your calculator, that's fine. Divide by 2. I would just leave it in your calculator, divide by 2. So your answer to 4 decimal places is a negative 0.4491. Okay, questions on that? Okay, this one's a little bit different. 4 to the x plus 1 equals 9. Step 1 says you need to do what? Isolate. How do we isolate? Take away 1. Okay? So 4 to the x power equals 8. Okay? I feel like a lot of times people see this and they're like, oh, it's 2. Because 4 times 2 is 8, but 4 to the second power is not 8. So be careful there. What do you do next? Take the log of both sides. So log 4 to the x, and again, if you want to right there, you can just say x log 4. That's fine. But for those of you that don't see it as quickly, I will do it this way. So now we're going to move this out in front. X log 4 equals log 8. Okay, what do you do next? Divide. You're going to plug that into your calculator. Divided by log 4. Don't forget the parenthesis. To the 4th decimal place, what do you get? Oh, there is. This one works out much nicer. 1.5. Right? 4 to the 3/2 power is 8, if you think of it that way. Square root 4. and take it to the third power. So technically, you didn't even have to use this method. You could have done our old method on this one and gotten there just fine. All right. Letter D. Hmm? 3 to the 2x plus 1 equals 12. Okay. Now, be careful here. You have 2x plus 1 as your exponent. Don't go subtracting 1 right now. It's part of your exponent. Is your exponent isolated? Yeah. Okay. So once you've isolated, take the log of both sides. So it's going to be log 3 to the 2x plus 1 equals log 12. Again, we're going to take that whole thing and we're going to move it out front. And I feel like this is where people sometimes want to do the wrong thing. Okay, we move that out front. So many times you're used to seeing parentheses with something multiplied by it and you want to distribute. Don't distribute, okay? What you're going to do here is exactly what we did before. We're going to divide by log 3 on both sides. Okay, so we get 2x plus 1 is left on the left. When you divide that, you get 2.2619. Okay, and from here, if you want to just do it in your calculator, that's fine. What's your next step? Subtract 1. So you would get 1.2619 equals 2x, and then divide by 2. So x is approximately 0.6309. Questions? Okay, last one. Just make sure you got that idea down. You have 2 to the 3x minus 1 equals 5. Isolate. What do you got to do? Nothing. It's already isolated. Step 2, what do you do? Take the log of both sides. So log 2 to the 3x minus 1 equals log 5. Then what? Move this out front. So it's going to be 3x minus 1 times log 2 equals log 5. What's next?
Divide.
Don't distribute, right? Divide by log 2, divide by log 2. Don't forget your parenthesis. This is gone. So you have 3x minus 1 equals log 5 divided by log 2 is 2.3219. And from there, I'm fine with you doing it on your calculator. Add 1, divide by 3. So if we add 1, you get 3.3219 equals 3x. Divide by 3, and we get x is approximately 1.1073. Questions on that? The end.